Hello everyone. Today we're going to explore the KPI Builder through a practical use case. We're currently logged into the Devum HR tutorial application. Now let's understand the scenario. When an employee logs into the HR portal, they are presented with a personalized dashboard. This dashboard is tailored specifically to the logged-in user. For example, here we have Ashok Kumar logged into the system. This is his personalized dashboard view. For each leave type, the system displays both the total number of leaves allocated and the remaining balance. Employees can clearly view different types of leave, including casual leave, sick leave, vacation leave, special leave, and earn leave. For example, if an employee is granted 10 vacation leaves in total and has already used 7, the dashboard will automatically show the updated balance as 3 remaining leaves. This is the KPI dashboard we've built, and next we'll walk through how to create it step by step. To create the KPI, we begin by navigating to the App Studio and opening the KPI Builder. Here, we click on Add New and provide a display name for the KPI. We named it as Employee Leave Balance _KPI. A description can also be added, which is optional. We select the frequency as No Period. Next, we select the mode as Reactive. And define the time period with a 1-second duration and batch size of 1. We then proceed to configure the parameters by clicking on Create Params. Here we choose an anonymous schema. Name it as Leave Balance Input and add the required fields such as user ID and data type as string value and checkmark the is optional. Then the next field as year YD and data type as string value and checkmark is optional. Once done, we move on to define the response. Again, we select an anonymous schema and name it as Leave Balance Output. We start adding fields like name, leave allocated, and leave balance with appropriate data types. First, we added field as leave type a name. Selected data type as string value, checked marked is optional. We repeated the same for another field named leave allocated. Data type as double, checkmarked is optional, then added another field called leave balance. Data type as double and checked marked is optional. We checked is the response an array. After reviewing the response, we saved the configuration. Next, we create a service by selecting Create Fluent or Domain Service and naming it as Employee Leave Balance KPI. We also add a description explaining that this KPI provides employees with a clear, personalised view of their annual leave status, including total allocated leaves and remaining balance. Finally, we save the service to complete the setup. Now that the service is created, we move on to building the logic. We navigate to the Service Builder to start configuring the flow. Here, we expand the Functions section and select the required functions to begin designing our logic. To keep things efficient, we'll quickly set up the logic needed for this KPI. Now, coming to the domain service. To save time, the service has already been built. In this flow, we are calculating two key values: the leave allocation and the leave balance for a specific employee. So essentially, this logic is responsible for driving the KPI that we will display on the dashboard. To achieve this, we are using multiple schemas. First, the employee schema, which stores all employee-related details. Next, the leave apply schema, which contains all leave application records. Then, the employee leave type schema, which defines how many leaves are allocated to each employee. And finally, the leave type schema, which acts as a master list of all available leave types. So together, these schemas give us both allocation and usage data. Now let's start with identifying the employee. We use the DB filter function to fetch the employee record from the employee schema. Here, we match the user ID with the stored employee data. This ensures that all further calculations are performed only for the logged-in user, making the logic dynamic and user-specific. Next, we retrieve leave applications. We use the DB filter function on the leave apply schema. As we are passing two inputs into this service, the first is the user ID, which helps us identify the currently logged-in employee, and the second is the year, selected from a drop-down which allows us to filter leave data based on a specific time period. So here we apply two conditions, one based on employee ID and another based on the selected year. This step is important because this ensures we only get the leave records relevant to the current employee for that year. After that, we fetch the leave allocation data. This is done using the employee leave type schema. Again, we filter by employee ID. This gives us a clear view of how many leaves are allocated to the employee for each leave type. Now, we retrieve all available leave types from the leave type schema. This acts as our reference list. We will use this list to iterate and calculate values for each leave type individually. Now, to process each leave type, we use a map function. This allows us to iterate through every leave type one by one. Instead of handling all data together, we perform calculations separately for each type, which gives us more control and accuracy in the results. Inside the map, the first step is to fetch the allocated leaves for each leave type. Here, we are working with the allocation dataset that we retrieved earlier. Now, for every leave type in the iteration, we need to identify how many leaves have actually been assigned to the employee. So, to achieve this, we use the Find First function on the allocation dataset. We compare the current leave type with the leave type present in the allocation records. And finally, this gives us the number of leaves allocated for that specific leave type, which will be used in the next steps of the calculation. Next, we fetch the applied leaves. We use the filter function on the leave applications dataset. We match records where the leave type equals the current iteration. This gives us all the leaves applied under that specific leave type. At this stage, we have all the leave records for the employee, but not all of them should be considered for calculation. This is because some of these leave applications may have been cancelled. Cancelled leaves should not impact the final leave usage, so we need to explicitly remove them from our dataset before proceeding further. To handle this, we apply another filter condition on the leave records. Here, we check the status of each leave entry and identify which ones are marked as cancelled. Once identified, these cancelled records are separated out from the rest of the data. So by excluding cancelled leaves at this stage, we make sure that the calculation reflects the actual leave usage accurately. Once we have the filtered data, we calculate totals. We sum the number of days for applied leaves. Then we separately sum the number of days for cancelled leaves. These two values help us derive the actual leave usage. To calculate the actual applied leave, we take the total number of leave days that were applied by the employee. From this total, we then subtract the number of leave days that were cancelled. This step is important because cancelled leaves should not be counted as actual usage. By performing this subtraction, we are left with only the valid leave days that were truly utilised. This gives us an accurate representation of the actual applied leave balance. Next, we convert the allocated leave value into a double format using the convert to double function. At this stage, the allocated leave value is typically available in a different numeric format, such as long. However, the final response expects the value to be in a decimal format. So, to ensure compatibility with the expected output structure, we explicitly perform this type conversion. By converting the value into a double, we make sure that the data is consistent and can be accurately used in further calculations or displayed correctly in the UI. This step helps maintain uniformity in the response format, especially when dealing with numeric values across different operations. Now we calculate the leave balance. We subtract the actual applied leaves from the allocated leaves. This gives us the remaining leave balance for that leave type. Finally, we construct the response using the MVU response builder. Here, we map the key values like leave allocated to converting allocated leave to double, leave balance to actual leave balance, leave type name to each dot name. This step basically formats the data in a way that the UI can directly consume. The response generated inside the map function is returned as the output for each leave type. At this stage, each iteration of the map produces a structured result specific to that leave type. Here, we define the appropriate return type and pass the result for each leave type accordingly. This ensures that every individual record follows a consistent structure before being combined. Once all leave types are processed through the map, we have multiple individual results, each representing a different leave type. These individual results are then combined together into a single consolidated response. This step is important because the UI expects a unified dataset rather than separate outputs. Finally, this complete response is returned from the main action and sent to the page. Now that the logic is ready, the next step is to bind this data to our dashboard. We have already created a container where the KPI data will be displayed. Inside this container, we will show the allocated leaves and the leave balance. To begin, we go to the outline panel and select the container. Within the container, we select the unpaginated list component, which is used to display the data dynamically. Now we navigate to the Properties panel and go to the Data Source Binding section. Here we add a new data source. We select the KPI or MView option and choose the service, Employee Leave Balance KPI. At this point, the data source has been successfully selected. You can see that the service is now connected to the component. This means the UI is ready to receive data, but before that, we need to define how the input parameters are passed. So next, we will proceed with the parameter mapping. Then we select the appropriate method and proceed to configure the mapping. Next, we define the parameter mapping. First, we map the user account ID, which identifies the logged-in employee. Then, we map the year parameter by selecting the value from the drop-down. Mapping start date and end date is mandatory in KPI. In this case, a date range control is being used. The decision has been made to pass the date and time value from the start date time event. Therefore, navigate to the start date time event. Select the start date time value from the drop-down list and click on the Map button. Similarly, click on the End Date field in KPI and navigate again to the Date Range control. Here, the decision has been made to pass the date and time value from the End Date Time event. Therefore, navigate to the End Date Time event, select the End Date Time value from the drop-down list and click on the Map button. Finally, we mark the required parameters. Once all mappings are completed, the data source is fully configured. At this point, we can see that placeholders are available for the leave-related data. Now we bind this data to the UI. We select the unpaginated list, right-click, and choose Data Binding as shown in the video. Then we bind it to the Employee Leave Balance KPI data source. Once selected, we can see that the list starts receiving the leave type names. Next, we bind the allocated leave value. We select the corresponding field, open Data Binding, and map it to the leave allocated attribute. After applying the changes, the allocated leave values are now linked to the UI. Similarly, we bind the Leave Allocated field. Again, we open Data Binding, select the appropriate parent context. Here, a single control has been selected. Using the HTML template, the leave allocated count can be displayed along with the title such as allocated and the count value, while days is added as a static value. The template is already available here. By entering the response field, name wherever want to display it. List of response field will display and select required one. It will automatically be added to the template. Click on Apply button and check now actual leave allocated count is updated along with HTML template. Similarly, right-click on the control and select Data Binding. Then choose the parent data source and navigate to the Template section. Here, the template is already available. Repeat the same data binding process that was done for the allocated count by adding the balance count response field to the template and applying the changes. This configuration will ensure that the balance count is dynamically displayed along with the existing template content during runtime. Once all bindings are completed, the UI is fully connected to the service output. We can now see the leave type, allocated leaves, and remaining balance displayed dynamically for the employee. Finally, we publish the application. This allows us to view the dashboard with all KPI values rendered correctly, and that completes the data binding process for the KPI dashboard. Thank you.